Hello again, this is Susan Poss. I'm still working in section 10.5 on graphing parabolas. The ones that we've graphed so far, we've looked at vertical shift, which is the number outside the squaring portion of the function, and we've also looked at horizontal shift, which is the number on the inside of the squaring portion. So now we're going to be looking at what happens if you have a multiplier sitting out in front of the second degree variable. So again, just like we started out before, I've picked some numbers over here in a little table, and you're going to see me plugging those numbers in, and you can watch and see what happens. So when x is -2, remember your order of operations. You have to square the -2 first, and then multiply by 2. So squaring first. And this is where you'll start to see the symmetry take over. And you'll start to see these numbers repeating. All right, so there are 5 points. Let me run over here and graph those 5 points. -2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Looks like -2, 8 is right there. -1, 2 is here. 0, 0 is here, 1, 2 is there, and 2, 8 is here. I'm going to sketch this in. It's kind of hard to see. Let me go back and put the parent in here. So if I put the parent in pink, I hope you can see that the new function that has the multiplier of 2 in front, that's the one in green, is more narrow. It's skinnier. It accelerates faster as it moves upward out the top of the graph. The vertex on this one is still the origin. There's no horizontal shift and no vertical shift. And the axis of symmetry is still running right through the vertex, and it still has the equation x equals, in this case, 0. So when there was a multiplier of 2 out in front, I need you to start taking note here. The picture, the graph, became more narrow than the parent graph. So we're going to look at one that's got a fraction out in front. So instead of a 2 this time, I've got a 1/4. So let me probably bore you for a few minutes here with some numbers again. And again, because of the order of operations, the squaring has to occur first before you multiply by the 1/4. So 1/4 times 0 is 0. And again, this is where you start to notice, and I'm not going to do all of that work. Oops, that's not right. And quickly plotting points, -2, 1, -1 1/4, 0, 0, 1 1/4, and 2, 1. So let me see if I can sketch this parabola for you. And let me quickly go back and put the parent parabola in. Here's the parent. This is the basic f of x equals x squared. So I hope you can tell that when we had a multiplier out in front here that was a fraction between 0 and 1 here, it made the parabola wider. Some authors call this compressing it, flattening it out. Others use the word wider. So again, let's quick review. If there was a multiplier of 2 in front, it made it more narrow. If there was a multiplier of 1/4 in front, it made it wider. So again, quickly, let's get the vertex. It's still at 0, 0 right here. And the axis of symmetry is still x equals 0. All right, one last one here. What happens if the multiplier out in front is a negative multiplier? Oops, and it looks like I didn't create a little table for you here. So let me do that real quick. All right, so here we go. We're going to first, whoops, that's not what I want to do. We're going to first plug in with -2 for x. Square first, and then multiply by the -1/2. And this is where you'll start to see the symmetry. And again, by symmetry, I mean, notice how these values repeat, balance. So as I plot these points, -2, -2 is here. -1, -1/2 is right about there. 0, 0 is at the origin, and then I'm going to have these symmetric points. So it's pretty clear that that -1/2 did two things. The 1/2 made this shape a little bit wider than the original parent. Let me put that in a different color. You can't see that very well. Here's the axis of symmetry coming through the vertex. The vertex, of course, is still at the origin. And the axis of symmetry is at x equals 0. But the important thing that I want you to see here is that because of this negative out in front, it caused the parabola to flip upside down, or it caused it to rotate about the x-axis. So you're seeing a reflection about the x-axis. You'll hear those different words used by different authors and teachers. So the negative in front, again, causes a rotation or a reflection about the x-axis.